Hi all, last video with stoichiometric calculations before we get into some applications of it in the last video or last two videos of this unit. All right, we are looking now at finally the kind of the complete picture. This is the most common stoichiometric calculation because this is stuff that we can actually measure in a lab. We can measure out mass at the beginning of the experiment, we can do the chemical reaction, and then we can measure the mass at the end of the experiment, and we can determine whether we are getting the true amount or the amount we believe we should get out from the reaction versus what might actually come out of the reaction. So this is the biggest one and the longest one in terms of the most steps, but all we're doing is molar mass and mole ratio. Okay? So what we have here is, let's start off. I mean, we have a chemical reaction, we need to balance it as usual. So I have one SN, one SN, one H, 2H, there's going to be a 2 right here. I have 2H and 2 Fs, so I'm good to go. All right, so what does this lead us to? I start off every problem just like I always have. I start with the number given to us, 30.00 grams, I should write the formula, of HF, hydrofluoric acid. All right, I'm trying to get grams of tin 2 fluoride, which is SnF2. All right, well that is a completely different compound. So the first thing I need to do is I need to figure out how to change it to the other compound, and the only way to do that is to be in the mole. So I'm going to need to change grams of HF coming from that going to moles of HF. With moles and grams together, it's 1. Okay? What is the molar mass of HF? I need to add one H and one F together, and that's going to be 20.01. Okay? That right there, if I solved it, I'm now in moles of HF. Well, now that I'm in moles of HF, I can go from moles of HF to anything, to moles of anything with a balanced chemical reaction, but in this case, I want to go to SnF2. All right, where do I find the numbers for mole to mole? The chemical reaction. All right, SnF2 has a 1 in front of it, HF has a 2 in front of it. All right, but I'm not done, so here's the additional step, which we kind of have done, just not all of them together. I'm in moles of SnF2, so I'm going to come from that. Excuse me. And I'm going to go to grams of SnF2. Okay? When grams and moles are together, it's 1. And then I need to figure out the molar mass of SnF2. So 19 times 2 plus 118.71. 156.71. And I have set everything up. I'm going to multiply everything across the top, and then in my calculator I'm just going to hit divide in front of every number on the bottom. So 30.00 times 156.71 divided by 20.01 divided by 2. I get 117.4737. I have 4 sig figs here, which is unique. So I need to do 117.5 grams. And that is a mass to mass conversion. I went from mass of compound 1, I'm going to draw my diagram right here, and then we'll do 2 more, to moles of compound 1, to moles of compound 2, to mass of compound 2. I used a molar mass, I used the mole ratio, I used the molar mass. That is the process. If you take your time and you stay organized, hopefully will go very, very well. So let's try a couple more. We have 2 NAs, 1 NA, so I'm going to put a 2 here. I'm going to skip O's like I usually do. I'm going to go to H's. I have 2 H's, 2 H's, so I'm good there. I have 2 plus 1. I have 3 O's on this side, and I have 3 O's. Oh, no, I don't. I have 4 O's on that side. Ooh. So I'm going to have to do something. Let's see here. All right, I'm going to change that So this one you might have to play around with a little bit more. So, well, let's do my technique. Let's go back and start over and put a 2 right there and see what happens. So I now have 4 NAs, so I need a 4 right there. Let's still do H next. I have 2, I have 4, I'm going to put 2 right there. I now have 4 O's plus 2 for a total of 6 O's on this side. Hey, look at that, 4 plus 2 is 6. That works. Oh, don't erase that 4. All right, there you go. My little trick works again. All right, I have 50 grams of sodium peroxide, which is this guy right here. So I start with 50.0 grams of Na2O2, and I'm trying to go 2 grams of oxygen. I haven't said this out loud, but you can see my technique here where I write out what I'm going to at the very right-hand side of the paper or the page or wherever, like where I leave space, and I go, that's what I'm aiming for. Well, if I'm going from grams to grams, I can't switch it between grams and grams. I need to go from grams into moles first. So Na2O2 to moles of Na2O2. Grams and moles on 1 because I'm doing molar mass, which is 1 mole. And that's going to be 20 times 2 plus 32, 77.98. I'm now in moles of Na2O2, so I'm coming from moles of Na2O2 to moles of O2. Again, I could technically go anywhere, but I'm trying to find O2. I look at the chemical equation. O2, only 1, Na2O2, 2. I'm now in moles of O2. I'm coming from moles of O2, going to grams of O2, 1 mole, 32 grams. I can now calculate. Moles cancels out. 50 times 32 divided by 77.98 divided by 2. 3 sig figs, this is 10.3 grams. One last one. Again, you can always pause it and go, you figure it out on your own, and then come back and watch me. So if you want to pause it real quick, and then I'll go through it. All right, if you haven't paused, here we go. Even if you did pause. All right, balance the reaction, 1 mg, 1 mg. All right, I got 2 OHs, and again, here's my little trick with OHs, is if I have a water on this side, I can pretend like it's HOH. So I have 2 OHs on this side, I have 1, so I'm going to put a 2 in front of that. I have 1 H, which means I have 1 H, so I need to put 2 here, and 2 CLs, 2 CLs. It is all balanced. All right, I'm starting with 3 grams of magnesium hydroxide, this guy. So 3.00 grams of MgOH2. Whew, okay. I need to go up. I'm trying to go to grams of just magnesium chloride. So I'm coming from grams of MgOH2, going to moles of MgOH2, 1 mole, MgOH2, 24.31 plus 2 plus 32. I'm getting 58.33. I'm going to then go from moles of MgOH2 to moles of what I want, MgCl2. I look at my chemical equation. They're both 1. That's nice. And then I'm going to go from moles of MgCl2 to grams of MgCl2. That's 1. 24.31 plus 70.9, 95.21. I'm going to multiply by the 95.21 and divide by the 58.33. 3 sig figs. Whoop, this one's another one of those tricky ones where you got to round up the additional digit. 4.90 grams of MgCl2 would form. All right, so that's mass to mass. Those are all your stoichiometric calculations. Again, we're going to be moving into using those to do essentially real-life experimental type work, and how we can figure out how much we should put into a reaction, how much we hopefully will produce, and how much we actually produce, et cetera, as we move forward. All right, thank you very much.